One of the best ways to study logarithms is to derive its rules solely based on the definition of the logarithm. That's why you need to know its definition very well. Let's start with the definition and derive all the rules. And believe me, the better you internalize the definition, the easier the rest of the topic will become. If I say logarithm base a of b equals x, these symbols have the following meaning. A to the power of x equals b. Now, I wrote this by looking at these symbols here, because that's what they mean. But at the same time, by looking at these symbols here, I should also be able to write logarithm base a of b equals, I should be able to write x. In other words, I should be able to convert these symbols into each other. That is, I should be able to convert exponential numbers to logarithms, logarithms to exponentials. Once you can do this, you can easily derive all 11 rules. Let me show you. Now let's say we don't know that the logarithm base a of 1 equals 0. Let's say log base a of 1 equals x. What will happen from here? We'll say a to the power of x equals 1. I'm using the definition. Looking here, what should the exponent be here? So that the answer equals 1, x must be 0. Let's say it equals 0. So we've established our first rule. Let's move on to our second rule. Logarithm base a equals, it's said to be 1. We don't know. Logarithm a. Let's say log base a of a equals x and write our definition. I'll say a to the power of x equals a. What should x be for this equality to hold? Since the first power of a number is equal to itself, x will be 1 here. Let's write it, equals 1. So we've established our second rule as well. In our third rule, it's stated that log base a of a to the power of x equals x. We don't know the value of x here. Let's assume it. We've written something like this. Log base a of a to the power of x equals, let's call it y. Now using the definition here, what can I write? A to the power of y equals a to the power of x. Since the bases are the same, the exponents must also be the same. From here, I see that y is equal to x. Let's write here, equals x. Thus, we've also covered our third rule. Now, for our fourth rule, I'll go from left to right, or rather from right to left. So we've seen something like this. What does this mean? We can look at it like this. Let's call log base a of x k. Log base a of, let's call y n as well. Let's write these down. Log base a of x equals k. Log base a of y equals n. From here, let's apply our definition. A to the power of k equals x. A to the power of n equals y. Again, we've used our definition. Now here, I want to arrive at something like k plus n. That's why I'm going to go ahead and multiply these two expressions here so that I can see something like k plus n again. A to the power of k times a to the power of n equals. Isn't it x times y? The product of this and this will be equal to the product of that and that. When the bases are the same, the exponents are added. Equals x times y. Now let me write the expression I see here using the definition of logarithm. What does this mean? Let's see. Logarithm base ax multiplied by y equals k plus n. Now it's k's turn. And instead of n, let me write the transformations I initially made. So what was k equal to? Logarithm base ax. And n was logarithm base ay. Let's substitute these in. Logarithm base ax plus logarithm base ay. So I've derived this rule as well. So if there is a multiplication inside my logarithm here, it can be written as the sum of logarithms. Or conversely, if you have such a sum, you can write them as a multiplication. We've covered this rule as well. Our fifth rule is that logarithm base a of x to the power of n equals n times logarithm base a of x. What does this mean? The exponent of x comes in front of the logarithm as a coefficient. Let's see why. Now, what does logarithm base a of x to the power of n mean? Logarithm base a of x, and so on. Doesn't that mean multiplying n x's together? X to the power of n. All right. What did we learn in our fourth rule? We could write these multiplications as a sum in logarithms. Like this. We wrote it like this over and over again. We wrote them all down. There are n of them. Let's write the last one as well. So we've summed n logarithms of x to the base a. So what does this mean in mathematics? It means multiplying n by the logarithm base a of x. So we've covered this rule as well. We already did the multiplication version of this. Now it's time for the division version. Now let's call this k, and let's call this n. Let's write it down now. Logarithm of x to the base a equals k. Logarithm of y to the base a equals n. So what does this give us? I'm using the definition again. To the base a, ka to the power of k equals x. Let's write it here as well. To the power of n equals y. We've written it down. Now, in order to get something like x divided by y here, I divide both sides by each other. To the power of k divided by a to the power of n equals x divided by y. The bases are the same, the exponents are subtracted. A raised to the power of k minus n equals x divided by y. Now I will write the expression I see here using the definition of logarithm. Logarithm, a base x divided by what is equal to k minus. Now what was k minus what? The expression here. Look, what is k minus? Let's write it here instead. Logarithm base a of x minus logarithm base a of y. Here is our sixth rule. As you can see, it's a rule we easily derive thanks to the definition again. The base change property is the most important property of logarithms. 7. I will use the number 7 after the rule, and I will always use it in the rules and features as well. That's why we need to learn this very well. Now let's write the logarithm of x base a. What should it be equal to? To a randomly selected number n. I'm using the definition a to the power of n here. It will be equal to x. See, we've done the most important part again. The rest is downhill from here. Now I will take the logarithm of both sides. It doesn't matter which base you choose. For example, let's use base c. I'm saying this to keep it consistent with the previous part. Logarithm base c of a to the power of n equals logarithm base c of x. Now I know that the exponent here comes out as a coefficient in front. N times logarithm base c of a equals logarithm base c of x. Now I'm going to isolate n here. I'm moving this over here as a division. Look, here it's in multiplication form. Logarithm base c of x divided by logarithm base c of a. So what did I find? I can substitute it here. Now, logarithm base a of x equals logarithm base c of x divided by logarithm base c of a. After you learn to derive this on your own, which I repeat, this is the most important part. After doing this, you should take a step back and take a look, because you need to be able to memorize this. I mean, how am I going to memorize this? Actually, it looks very natural. Look, after creating a common base like this, x is on top, a is on the bottom. See here too, x is on top, a is on the bottom. At least that's how I memorized it. I don't really like explaining things like this, because everyone can have their own methods. What matters is the mathematics itself. But this time I felt like sharing it, because this rule is very important and you'll use it a lot. So if we're all set, we can move on to the next one. We're not ready yet, are we? It's not possible to get all of these right on the first try. So you took this on a piece of paper, wrote down the definition, and how many of the rules could you figure out? You managed to figure out 3 or 4 of them. Then you looked at the book and started figuring out 6 of them on your own. You'll keep going like this, step by step. In the end, when you figured them all out by yourself, you've earned your first certificate. After that, you can move on to solving questions. Right here, immediately. Let's use our feature number 7. So what is this? Logarithm. Look, a is below, b is above. B is above, a is below. You might ask, so what are the bases of these? If I don't write anything underneath, it means the base is 10. For example, these are written in base 10, but it does not really matter. So even if you write something else, you'll still get the same result anyway. Logarithm. I'm continuing. C is above, B is below. Now I'm applying the property I learned in number 7. Logarithm D is above, C is below. We've written them like this. Now, times logarithm n on top, m on the bottom. How's that? So number 7 makes a bit more sense now, right? Practice is a very important thing. You learn completely through practice what the rule actually is, not how it was derived. What was the most important thing? Deriving the rule yourself. I apologize for saying the same thing 150 times. These canceled each other out. So what's left? The logarithm of n over the logarithm of a base? A. How else can I write this? N on top, a on the bottom. I can write it as logarithm base a of n. Look, after learning property number 7, as you can see, I was able to derive number 8 very easily. I'm going to keep doing the same thing. 9. Our rule is a crazy one. Let's write it down first. Logarithm base a. A to the power of n as the base, b to the power of m. Now, the power of property number 7, b to the power of m on top, a to the power of n on the bottom. Logarithm. b to the power of m, look, it's on top. Logarithm base a to the power of n is on the bottom. Both have a base of 10. All right, we've written it like this. Now, what am I going to do? The exponents here come out as coefficients in front. Equals m. Logarithm b divided by n. Logarithm a. Equals. Now, I see something here as well, right? B is on top, A is on the bottom. M over n times logarithm B on top, A on the bottom. A is here, B is here. And so which rule number is this? We've solved it with rule number 9. But thanks to number 7, the power of 7, you really need to learn number 7 well. I've come to number 10. So what happened here? First, you need to take a look at what's going on here and understand it very well. Here there is logarithm b and logarithm b. So actually, the base of the logarithm here hasn't changed, but the bases of the two numbers I wrote above have been reversed and their contents have been swapped. Now that you've observed these things very carefully, you need to write about them and analyze them. I'm telling you mine, but please find yours. I had a fantastic geometry teacher, Hikmet Bashkaya. He was an incredible person. He had his own expressions like that. He would share it with us. He would say things like interwoven net and such. So did it help? It did, because it actually meant something. Look, I tried to do the same thing again. Look, the bases of the exponents here are the same. Here the ACs are swapping places, so you need to see this first. All right, okay. Let me write a to the power of log base b of c and call that x. The start of every ray. Then I take the logarithm base c of both expressions you see here. You might ask why. Well, I'm just playing around. That's what math is. I'm playing with mathematics. Since these two expressions here are equal, the logarithm base c on both sides. Look, since the expressions I put in parentheses here are equal, these will also be equal to each other. I played a little game like this. Let's see what happens. That's what I'm saying. Now here, the exponent of a is written. The coefficient could come in front of the exponent, right? Right? Logarithm base b of c times logarithm base c of a equals logarithm base c of x. After writing this, I'll turn to an old friend again. Look, pay attention to the c's here. I can write this as logarithm c divided by logarithm b. You know, we just showed a property involving simplification. I can also write this as logarithm a divided by logarithm c. So what is this again, actually? Again, we're using the 7th property, equals logarithm base c of x. Now, these cancel each other out. Logarithm a divided by logarithm b equals logarithm base c of x. Let's take this. Let's put it here. Let's continue from here. Now, there was a way to write this too, right? Logarithm a on top, b on the bottom. b on the bottom, a on top equals, I could write it as logarithm base c of x. I'm doing great. There's very little left until it's finished. What was I trying to find? Look, I had said x. I'm trying to find x. So now, again, I'm using the definition of logarithm. What does this mean? So I'm going to make this the base. I'm going to make this the exponent. And I'm going to say it equals this. Let me show it like this. How? Logarithm. So log base a of b equals x. Remember, I was saying a to the power of x equals b. This is the base. This is the exponent. And this was the right side of the equation. I'm going to do the same thing here. This will be the base. This will be the exponent. Then I'll say it equals x. Logarithm with base c of logarithm with base b of a equals, we wrote x. Now I need to substitute x here. This, let's take this and do it somewhere clean. Like this. Equals. What is it? Logarithm with base c of logarithm with base b of a. So as you can see, we've shown the equality between this and that. It was a long process for this one. You need to work on it a bit. You might not be able to do it on your first try. But look, while applying one rule or property, how many other rules am I using? So it's also a great way to learn the other rules. That's why I'm so fond of these. Let's move on to number 11. This is actually naturally like this. You'll ask, what does that mean? Naturally like this? Let me put it this way. To the power of log base a. I don't know that it's x equals, let's call it y. Now let's use the definition here. How is this written with the definition? Log base a of y equals logarithm base a of x. Now for these to be equal, x has to be equal to y, right? So this means x is equal. So that's how I derive this. But you might say, if it was this easy, why did you show this as number 11? It's because a to the power of log base a of x. It's actually so we can apply the rule we just learned. What was the rule? Now let's think calmly for a moment. Now look at this. A and x are switching places, right? According to our rule, because I wasn't touching the log a here. So I write x here. Now this is logarithm a. And here I write a in place of x. Equals. Here, x will be equal to 1. That is also equal to x. I've shown it again. By now, you must be convinced of how important it is to figure out the properties and rules on your own. Or maybe you think they're not important. Just memorize them and move on. Are they going to ask you for a proof when you're solving the questions? These are the most mistaken ideas. There's also this. You just forget them and move on. I mean, you memorize, you do it. Maybe it comes up in one exam, maybe it doesn't in another. But if you learn where these come from, you'll have them imprinted in your mind much more solidly. These properties, the topic becomes more permanent. And the time you spend learning actually adds real value to you. It doesn't just disappear. Let me put it that way, but I can't advertise it any more than this. I want to thank the follower who gave the idea for this video. I said, if there's something you're struggling with at school, share it with me. Let me help you. I think they specifically asked me for feature number 7, the 7th rule. But I said, since I'm at it, let me show all of them. Please, what are you doing at school? Let me know. What are you having trouble with? What are you dealing with in math? What is challenging you? I'll try to help you as much as I can. See you soon.